So we're looking at a new concept today. It's something that we've been playing around with already, but we're just going to be defining, labeling, using terminology for, and that is the discriminant. What is a discriminant? Well, let's first think about discriminate. It's a word we use. What does it mean to discriminate? Set apart, yeah, I like it. What are some other definitions we could give? Yeah, so there's a difference, right? The definition I'm going to write here is to note or observe a difference. Discrimination is where people are treated differently, which is not right, based on some differences. So this time we are looking at discriminating between different types of roots for a quadratic equation. We've already been looking at some of these different types of roots. Now, on our quadratic equation, b squared minus 4ac over 2a. Now, we've noticed that what is under the square root sign here affects what the roots are going to be like. If this 4ac is larger than b squared, what do we get? A negative number. If it's a negative number, what does that tell us about the roots? There are no real roots. Okay, what about if b squared is equal to 4ac? Yeah, okay, so then this becomes 0 and there is one root. Or we could think of them as two equal or repeated roots, as is sometimes said. Okay, what about if the number turns out to be a perfect square? So b squared minus 4ac is a perfect square. If that's a perfect square, you take a square root, we end up with rational roots. If the b squared minus 4ac, or the square root of that is not a perfect square, so b squared minus 4ac is not a perfect square, then the square root of that is a third, then we have two irrational roots. So this part of the quadratic formula really tells us a lot about the roots, and hence we call this the discriminant. You scroll up. So the discriminant here is b squared minus 4ac. Notice that we do have a triangle. The triangle means the discriminant, and it is actually, believe it or not, it's a capital D in Greek. It's actually delta. So we've used little deltas before, but this is the capital letter D. D for discriminant, and in maths we use a lot of Greek, so hence we're using capital D in Greek instead of capital letter in English. So that's what it means. So that discriminant tells us about what the roots are. So, let's calculate the discriminant for these. So I hope you've got your books there ready to do these examples. So our first one, A, is 4x squared minus 4x plus 1 equals 0. So we have our A, B, C. Well, we know that the discriminant, if you use my capital D, Greek, my delta, equals b squared minus 4ac. In this case, b is negative 4, so we have negative 4 squared minus 4 times, well, a is 4, c is 1. Negative 4 squared becomes positive 16. So we have 16 here minus, well 4 times 4 is 16 times 1 is 16 minus 16, so the discriminant here is 0. Okay, can I write on this part of the board? Will it be seen?
Move it.
Well, I'll just rub this out and I'll do
Okay.
part B here. I'll just give you a moment to write that down before I do part B. Give it a go before I get to it, so simply label your A, B and C, put it into the formula B squared minus 4AC and find out what the discriminant is for this quadratic equation. Can I rub it out now? Not yet? No worries. Just remember the discriminant is simply what is under the square root sign in your quadratic formula. Let's do B. This time our equation is 3x squared minus 5x plus 5 equals 0. Our discriminant is, of course, b squared minus 4ac. Well, a this time is 3, b is negative 5, and c is 5. Let's plug them into the formula. So, we have negative 5 all squared minus 4 times 3 times 5. Negative 5 squared is 25 minus, oh, we have 12 times 5 is 60. So we have negative 35. Is that what you got? So we have a negative this time. So if it's a negative, what would that mean about our roots? It means there has to be no real solutions.
Just for B?
Sorry, what's that?
Just for B?
Yeah.
Yes, yes. The other one, I would have equal or repeated roots. So this table here, it's in your notes on landscape, which is thankfully up and running again now. So if the discriminant is less than 0, it means you have no real roots. This means that it doesn't cut the x-axis and you have two options. Either it's up here, it's up above the x-axis, or it's below the x-axis at all points. If the discriminant is equal to 0, as we saw in A, it has two real roots, but they're equal roots, so it's kind of like just one root, right? Or we could think of them as repeated roots. So here, that means it just touches the x-axis. It could be above or below, but it just touches. Then we have two scenarios here if the discriminant is greater than 0. We know that there are two roots, two real roots that is, so that means it's going to cut the x-axis at 2 points, as we see in our diagrams here. If the discriminant is a perfect square, those roots are rational, but if the discriminant is not a perfect square, the roots are irrational. In other words, they have thirds in them. Any questions about that? That all makes sense? So far? Okay, well, we're now going to use the discriminant to find out whether the roots of these quadratic equations are real or unreal, rational or irrational, equal or unequal. So let's give it a go. have 4 is A, B is negative 12, C is 9. So let's find what the discriminant is. So B squared minus 4AC. B in this case is negative 12 minus 4 times A is 4 and C is 9. Well, negative 12 squared is going to be 144. Minus 4 times 4 is 16. 16 times by 9. And 16 times by 9 is once again 144. So the discriminant is 0. What does this tell us about the roots? Oh, not quite.
Oh, wait,
Two real.
So the roots are real?
What does it mean by repeated?
A good question. Roots are real. So there's only one root that you can give it, just touches.
Oh,
Okay? So when it says 2, it still says 2, but the 2 are equal. So in other words, it's like 1.
so it's only one touches the Y?
Yes,
The
the x. It only touches the x-axis once. Okay? So we know that the roots are real. What else can we say?
Rational.
They're equal and they're rational. And equal. Great. So that's our conclusion. So we'll put it therefore to show that's our conclusion from what we found out with our discriminant. Let's do B. Part B, so we have that's our A is 4, B is 11, C is negative 3. So, discriminant equals B squared minus 4AC. In this case, B is 11, so 11 squared minus 4. Minus by 4, A is 4. Minus by negative 3. Well, 11 squared is 121. Notice this, we have two negative signs. So this is going to be a plus. 12 times 4 is 48. So we have 169. Well, what does this now tell us? What could we conclude about our roots? So we know the roots are they going to be real? Yes, because it's a positive number, so we can say that they are real. What else could we say about them? Are they going to be rational? Yes. Why? Because this number is a perfect square. It's 13 squared. 13 squared is 169. So because it's a perfect square, we can say that they are rational. They are rational, and are they going to be equal or unequal? Unequal. They're two different ones. Does that make sense?
What do you mean by the two different ones unequal?
Okay, so they're only equal if the discriminant is 0. So what equal means is the equation is going to be something like this. It touches the graph just at one point. So in other words, two roots are equal because they both touch at the same point. There's only one. Yeah? Whereas here, the equation is going to be something like this.
Because they don't touch the X.
It touches the x-axis twice, so those roots are unequal roots.
Okay, the roots where
Yeah. Think of it this way. Equal roots basically means there's like one root. We always say that there's two and we say there's two equal roots. But in your mind, go, that basically means one. Okay? Unequal roots is going to cut it at two places.
Okay.
That makes sense?
Yeah.
Good. Let's do C. So our A is 4, our B is 3, and our C is 1. Let's find the discriminant. B squared minus 4AC. Well, B in this case is 3. So 3 squared minus 4 times by A is 4, and C is 1. Well, 3 squared is 9. So 9 minus 4 times 4 is 16. 16 times 1 is 16. Oh, this isn't looking good. What does it look like? We're going to get a negative number. We're going to get negative 7. So what do we say about our roots?
No real roots.
There are no real roots. Well, that is all the theory that we have for today. I want us just to practice using the discriminant, and we will be later in this topic applying the discriminant and what that actually means for equations. But before we can actually apply using the discriminant, we should practice finding it, so you're very confident with finding it and very confident making those conclusions about what the discriminant means in regard to the roots. Let's just have a quick reminder, we have our test, our NISA task, on Friday. We have one class between now and then, which is Wednesday, which will be a revision class. We will do the NISA task, period 4, which means that we will continue on with this period 6. Any questions? Oh, Rowan, do you want to just turn the video off?